A new chapter is beginning in the EV industry. On the surface, everything looks normal, but beneath it all, something major is shifting. Recently, Elon Musk spoke about a rare earth-free motor. At first, it sounded like just another technical upgrade. But the real question isn't whether a motor can function without rare earth materials. The real question is, what hidden innovation is behind it? And could it completely reshape the electric vehicle market? The truth is, today's entire EV industry depends heavily on certain rare metals. If a company manages to break that dependence, the competition won't just be about price anymore. It will be about control. Who can produce it first? Who can scale it fastest? And who will fall behind? Industry whispers have already started. Is this simply a new motor design or the beginning of the biggest technological shift the EV world has ever seen? How is Tesla's move pushing companies like Toyota to rethink their strategy? And why could this decision disrupt the electric vehicle market in the coming years? By the end of this video, you might see the future of EVs in a completely different way. Before we dive into Tesla's new motor, let's take a quick look at Tesla's journey. Today, when we hear the name Tesla, we think of futuristic cars, advanced automation, and cutting-edge technology. But there was a time when people laughed at the idea. Many believed that no one could change the world with an electric car. Elon Musk was often seen as a wealthy dreamer, pouring money into what critics called impossible ideas: rockets and electric cars. Tesla was actually founded in 2003 by Martin Eberhard and Mark Tarpenning. Their goal was bold: build a car that didn't use gasoline but was just as fast and stylish as a sports car. Elon Musk wasn't one of the original founders. However, in 2004, he invested in the company and gradually became its most recognizable face. Back then, the term EV was associated with slow, unattractive, impractical vehicles. Tesla changed that perception in 2008 with the launch of the Roadster. The Roadster was the first electric sports car that could accelerate from 0 to 100 kilometers per hour in just about 4 seconds. It shocked the world. But success didn't come easily. In fact, 2008 nearly marked the end of Tesla. The company was running out of cash, facing serious production challenges, and investors were backing away. At that critical moment, Elon Musk invested a large portion of his own fortune into the company. Many people thought he was taking a huge risk, even acting irrationally, but he refused to give up. Then came 2012 and the launch of the Model S. That's when Tesla truly began to surprise the world. The Model S wasn't just electric, it was luxurious, long-range, and high performance. For the first time, people started to believe that electric vehicles could represent the future of transportation. After that, Tesla's momentum only grew stronger. The Model X arrived in 2015, bringing innovation to the SUV segment. In 2017, the Model 3 launched and marked Tesla's entry into the mass market. It made electric cars more accessible to everyday buyers. Then came the Model Y, which further strengthened Tesla's position in the global SUV market. Today, Tesla isn't seen as just a car manufacturer. It's viewed as a technology company. Let's look at the numbers. In 2015, Tesla sold around 50,000 vehicles. By 2020, that number had grown to roughly 500,000. In 2021, sales jumped to about 936,000 vehicles. In 2022, Tesla delivered approximately 1.31 million cars. And in 2023, that number climbed to around 1.8 million vehicles worldwide. A company that people once doubted is now selling millions of cars every year. But Tesla didn't just sell vehicles. It changed the image of EVs. It proved electric cars could be fast, powerful, and desirable. The supercharger network, over-the-air software updates, autopilot features, all of these innovations helped set Tesla apart from traditional automakers. Today, Tesla operates in major markets like the United States, Europe, and China. With its gigafactories, it continues to expand production rapidly. That's why when Elon Musk talks about a rare earth-free motor, the world pays attention. Because while the EV industry may look futuristic and strong from the outside, it has a hidden weakness: its dependence on rare earth materials. And if that dependence is broken, the entire balance of power in the electric vehicle market could change forever. Silent cars, fuel-free travel, vehicles controlled by large digital screens. It feels like the future has already arrived. But beneath this polished surface lies a reality that isn't talked about very often: a deep dependence on rare earth metals. Most electric vehicles today use permanent magnet motors. Inside these motors are powerful magnets made from rare earth elements like neodymium and dysprosium. These magnets allow the motor to produce smooth torque, high efficiency, and a compact design. The speed, performance, and responsiveness of an EV depend heavily on them. The problem? These metals aren't as common as materials like iron or copper. They're limited in supply and difficult to extract. And that's where the real vulnerability begins. Whenever an industry relies heavily on a limited resource, stability becomes a concern. Prices can spike unexpectedly. Supply chains can be disrupted. And when that happens, manufacturing costs rise. If rare earth materials become more expensive, motors become more expensive. And if motors become more expensive, the cars themselves become more expensive. So the affordability of electric vehicles is directly connected to these hidden materials most people never think about. But this issue goes far beyond cost. There's also the question of geopolitical control. Rare earth mining is concentrated in only a few countries around the world. That means supply isn't controlled purely by market demand. It's also influenced by political decisions. If exports are restricted or supply decreases for any reason, the entire EV industry could feel the impact. This is the quiet weakness of today's electric vehicle market. From the outside, everything looks strong and futuristic. But underneath, there's a dependency loop that's difficult to break. While companies are constantly innovating in battery technology, the core of the motor system still largely depends on rare earth elements. Now let's look at the global picture. Rare earth mining happens in very few regions worldwide. As a result, EV manufacturers across the globe depend on a narrow and fragile supply chain. This dependence is not only economic, it's strategic. Any country that controls rare earth resources holds indirect influence over the future of the EV industry. This creates significant supply chain risks. If mining operations slow down, logistics are disrupted, or exports are reduced, production can quickly be affected. Manufacturing timelines may be delayed. Large-scale production plans could slow down. Political leverage becomes a powerful factor as well. Countries rich in rare earth resources can influence the broader technology sector, because electric vehicles aren't just cars anymore. They are becoming the foundation of future transportation systems. Then there's the risk of a production bottleneck. If materials are limited, production capacity is limited. Even if companies want to produce EVs at massive scale, they can't do so freely if essential motor materials are scarce. That's why the future of electric vehicles isn't as secure as it may seem. Technology is advancing rapidly, but its foundation is still tied to a resource that isn't entirely stable. And this hidden weakness could trigger one of the biggest transformations in the industry. When Elon Musk mentioned the idea of a rare earth-free motor, many initially saw it as a simple cost-cutting strategy, an attempt to make production cheaper. But if you look more closely, it may represent something much bigger. Removing the rare earth dependency that today's EV industry relies on is no small task. Developing such a motor isn't just an engineering challenge. It's a strategic move to break free from supply chain limitations. If a motor can operate without rare earth elements, companies would no longer be dependent on scarce materials that could become expensive or unavailable at any time. That's what makes this shift so significant. If Tesla successfully develops and scales a rare earth-free motor, it could reduce its reliance on the same global supply chains that most of the industry still depends on. This would allow for more stable production planning, without the constant risk of sudden price increases or material shortages. Now let's step back and look at the evolution of EV motor technology. Electric motors didn't reach today's level overnight. It has been a gradual journey, with each milestone pushing the industry forward. In the early stages, most electric vehicles relied on permanent magnet motors. These motors offered high power in a compact size, along with excellent efficiency, which made them ideal for modern EVs. And that's where the story of motor innovation truly begins. This is exactly why permanent magnet motors became so popular so quickly. They delivered strong performance and impressive efficiency in a compact size. But as we discussed earlier, they also came with a major weakness: dependence on rare earth metals. While they provided power, they also introduced supply risks and cost uncertainty. This is where Tesla chose a slightly different path. In its early Model S and Model X vehicles, Tesla used induction motors. Unlike permanent magnet motors, induction motors don't rely on rare earth magnets. Instead of using permanent magnets, they generate a magnetic field electrically. That means there are no rare earth materials inside the motor itself. This approach helped Tesla avoid rare earth dependency. However, it came with its own trade-offs. Induction motors are generally a bit less efficient and may require more energy to deliver top-level performance. Even so, Tesla proved that induction motors could still be powerful and competitive. For the first time, people saw that electric vehicles could be fast and capable even without permanent magnets. But the evolution didn't stop there. As the EV industry matured, manufacturers began searching for a balance between performance and efficiency. In some models, permanent magnet motors made a comeback. In others, induction motors continued to be used. Now the industry appears to be approaching another turning point: hybrid motor concepts. The new thinking is simple. Why rely on just one technology? Could a motor combine the independence of induction systems with the efficiency of permanent magnets? This is the direction next-generation motor technology is beginning to explore. Tesla has a history of challenging traditional approaches. It played a key role in bringing induction motors into the spotlight. Now, the discussion around rare earth-free motors feels like the next logical step, almost as if the company is rethinking motor design from the ground up. And this is where things become truly interesting. A rare earth-free motor doesn't just mean removing certain metals. The real transformation could be in how the motor operates. Most current motors use permanent magnets that create a constant magnetic field. That steady field allows the motor to spin. But if there are no permanent magnets, how does the motor rotate? This is where a new design philosophy comes in: an electromagnetic shift. Instead of relying on a constant magnetic field, the motor could generate a controlled magnetic field dynamically. In other words, the magnetic field inside the motor would be created electrically and adjusted in real time based on demand. That would mean the motor is no longer a fixed mechanical system. It becomes responsive and adaptable. And this isn't just about hardware. Software becomes equally important. Advanced control software could manage the motor's behavior in real time, deciding when torque is needed, how much power to deliver, and at what speed. Every movement could be optimized through intelligent algorithms. In this scenario, the motor isn't powered by electricity alone. It's guided by software intelligence. Then comes advanced torque management. In traditional permanent magnet motors, torque delivery is relatively consistent because the magnets are always active. But if the magnetic field is generated dynamically, torque can be adjusted more precisely. More power when accelerating, less power during light driving conditions. This level of control could significantly improve overall efficiency. In other words, rare earth magnets could potentially be replaced by a system built around electrically controlled magnetic fields instead of permanent ones. Such a system would make the motor more flexible and adaptable. What makes this even more fascinating is that none of this change would be visible from the outside. The car would look the same, it would sound the same, it would perform the same. But internally, the core mechanism could be completely different. And that hidden transformation might turn rare earth-free motors from a simple material change into an entirely new direction for the EV industry. Now let's consider the impact on competitors. If a rare earth-free motor truly succeeds, the consequences won't be limited to Tesla. It could affect every automaker that has built its EV strategy around permanent magnet motors. Companies like Toyota, BYD, and many traditional automotive giants. Today, many of these manufacturers design their electric vehicle platforms under the assumption that rare earth magnets are essential components of the motor. If that assumption changes, the entire competitive landscape could shift. Right now, many automakers have built their entire EV ecosystem around permanent magnet motors. Their supply chains, manufacturing processes, and vehicle designs are all structured with rare earth materials in mind. But if a motor system proves that it can deliver strong performance without relying on rare earth metals, it could challenge that entire foundation. Imagine Tesla's approach succeeds. Other companies would then face a serious question. Should they continue investing in their current motor designs or completely change direction? If a rare earth-free system turns out to be cost-effective, scalable, and stable, traditional motor designs could slowly lose their appeal. That would put existing motor architectures at risk of becoming outdated. Systems that were once considered the industry standard could suddenly feel old-fashioned. And this shift wouldn't just affect technology, it would impact manufacturing strategy as well. Changing a motor design isn't simple. It requires adjustments to production lines, supplier contracts, component sourcing, quality testing, and certification processes. In other words, companies might have to rethink their entire manufacturing model. For legacy automakers, this could be especially difficult. Their operations are large, complex, and deeply established. Major structural changes aren't easy to implement. Newer, more agile companies built on innovation may be able to pivot faster. That's why rare earth-free motors could become more than just a technological upgrade. They could create pressure across the entire industry, forcing manufacturers to reconsider long-term strategies. If that happens, EV competition won't revolve only around batteries and driving range anymore. Motor design itself could become a new battlefield. Now we arrive at one of the most important questions. If rare earth magnets are removed, what happens to performance? Will efficiency drop? Will acceleration suffer? Will driving range decrease? This is the energy efficiency trade-off dilemma. Permanent magnet motors are highly efficient because the rare earth magnets inside them maintain a constant magnetic field. The motor doesn't need to repeatedly use extra energy to generate that field. It's always there. That's one of the reasons these motors are so efficient. If those magnets are removed and replaced with a field-controlled system, the motor would need to generate its magnetic field electrically. That could require additional energy. And this is where the engineering challenge becomes serious. Elon Musk has suggested that the goal isn't just to eliminate rare earth dependency, it's to do so without sacrificing performance. In other words, the aim is not just independence, but equal or even better efficiency. But achieving that balance is far from simple. If a motor has to continuously generate its own magnetic field, efficiency could decline. And in electric vehicles, efficiency directly affects driving range. Even small losses can reduce how far a car can travel on a single charge. This is where advanced software becomes critical. Next-generation motors may not depend solely on hardware improvements. Instead, intelligent software systems could manage the balance. The software could determine when to strengthen the magnetic field, when to reduce it, when to increase torque, and when to conserve energy, all in real time. That way, the motor only uses energy when necessary instead of constantly operating at full intensity. This means efficiency might not depend purely on physical magnets, but on smart control systems. In the end, the real competition may not be magnets versus electricity. It could be hardware versus intelligence. And that leads to the next major shift, the future of EV competition. Until now, the biggest battleground in the EV industry has been battery technology. Which company offers longer range? Who can charge faster? Who can reduce battery costs? These questions have dominated the conversation. But if motor technology also undergoes a major transformation, a new area of competition could emerge. In the future, the EV race might not just be battery versus battery, it could also become battery versus motor. One company may lead in battery innovation, while another gains an advantage in motor design. One might excel in efficiency, another in scalability and production stability. This could reshape the balance of power in the EV industry. Manufacturers that once focused primarily on battery development may need to give equal importance to motor technology. If motor design begins influencing cost, supply chain stability, and production scalability, it could become just as critical as the battery itself. In that case, the true strength of an electric vehicle in the future won't be defined by its battery alone, but also by the intelligence and design of its motor system. And this might be the shift that has the power to redefine the entire EV competition. Now let's think long-term. If rare earth-free motors truly succeed, their impact won't stop at engineering breakthroughs. They could influence the entire future of the electric vehicle industry. First, let's talk about cost. Why do EVs still feel expensive today? Batteries are a major factor, yes, but motors and their supply chains also contribute significantly. Rare earth metals don't have stable prices. Sometimes they spike, sometimes supply tightens, and when that happens, vehicle production costs rise. If motors no longer rely on rare earth materials, one major cost variable could be reduced. This doesn't mean EVs would suddenly become cheap overnight, but it could create a pathway toward gradual and sustainable cost reductions. And that opens the door to something big, the possibility of a $20,000 electric vehicle. Right now, many EVs remain slightly out of reach for average buyers. But if motor technology becomes more affordable and easier to scale, building low-cost electric cars, comparable in price to petrol vehicles, could become more realistic. This wouldn't just benefit individual customers, it would also impact fleet operators, taxi services, delivery companies, logistics providers. Many of them want to transition to electric vehicles, but high upfront costs slow them down. If EV prices decrease and production becomes more scalable, fleet electrification could accelerate rapidly. Imagine thousands of taxis, delivery vans, and trucks switching to electric at a lower cost. Operating expenses would drop. Adoption would increase faster. Then there's the developing world. So far, EV adoption has been strongest in developed nations with strong infrastructure and higher purchasing power. In many developing regions, affordability remains the biggest barrier. If rare earth dependency decreases and motor production becomes more flexible geographically, local manufacturing could expand. Countries wouldn't need to depend as heavily on importing specialized materials. That could make EV production and sales more viable in developing economies. In that case, electric vehicles would no longer be a technology mostly accessible to wealthy nations. They could gradually become a truly global solution. This transformation wouldn't happen overnight, but it could be profound. Lower costs, higher production capacity, reduced supply chain risk. Together, these factors could reshape the trajectory of EV adoption. Rare earth-free motors wouldn't just represent a technical upgrade, they could help make electric mobility accessible to everyday people. If this technology scales successfully, its influence won't be limited to one company or a handful of models. It could shift the balance of the global EV market. Right now, the EV ecosystem is delicately balanced. Some countries lead in technology, others dominate supply chains. Some specialize in manufacturing efficiency. Rare earth resources play a key role in that balance. Nations that control these materials indirectly influence global EV production. But if motors no longer require rare earth elements, that balance could change. The first major impact would be on the supply chain. Today, many automakers rely on a limited number of sources for rare earth materials. If motors can be produced without them, manufacturing could expand into more regions. EV production would no longer be concentrated in just a few countries. This could reshape the global manufacturing landscape. New companies, new regions, and new markets could enter the EV space without facing the complexities of rare earth sourcing. Next comes price competition. If some manufacturers begin producing affordable vehicles using rare earth-free motors, others will be pressured to lower their prices as well. Global price competition could intensify, especially in price-sensitive markets like Asia, Africa, and Latin America. Until now, EV growth has been strongest in developed markets, but lower costs could unlock entirely new regions. At the same time, technological competition would evolve. So far, most innovation efforts have focused on batteries, longer range, faster charging, lower costs. But if motor design starts playing an equally important role, a new wave of innovation could begin. Companies would compete not only on range and charging speed, but also on motor efficiency, adaptability, and scalability. Investment trends could shift as well. Instead of focusing heavily on rare earth mining and related supply chains, companies and investors might direct more resources toward advanced motor designs, smart control software, and innovative manufacturing processes. Perhaps the biggest impact would be on the speed of global EV adoption. If costs fall, supply stabilizes, and production scales up, electric vehicle adoption could accelerate dramatically worldwide. In that sense, rare earth-free motors wouldn't just be another engineering improvement. They could become a turning point that shifts the balance of the global EV market. In the future, EV competition may not revolve solely around technological features. It may also be about access, production strength, and supply independence. And that shift could ultimately determine the direction of the entire industry. If you enjoy in-depth and easy-to-understand technology content like this, consider subscribing so you don't miss the next big transformation shaping the future.